Okay, here comes the 3.8 homework. We're going to rewrite each polynomial as the product of two factors. That means we're going to factor it. Okay? So, okay, let's do it. This guy right here, this is the difference of two squares. All right? Notice how there's two terms. 49 is a perfect square. X to any even power is a perfect square. And 144 is a perfect square. And we have a minus in the middle. That's all the reasons why it's difference of squares. Here's the big thing to remember. X to any even power is a perfect square. A lot of times we think that x to the fourth is a perfect square because 4 is a perfect square. No, it's a perfect square because 4 is even. So like x to the sixth is a perfect square because it can be written as x to the third squared. Okay, it's a square. All right, here we go. All you got to do for difference of squares is make me two sets of parentheses. Put a plus sign in one and a minus sign in the other. And then you're just going to square root everybody. Square root of 49, 7. Square root of x to the fourth, x to the second. Divide the exponent by 2. See what happened with 6? The square root of x to the 6th is x to the third. Because it's x to the third times x to the third. Okay. And then 144, square root of 144 is 12. So we have 7x squared plus 12. We have 7x squared minus 12. And that's it. Number 2. We have another quadratic trinomial. Even though it doesn't look quadratic, it can be factored just like a quadratic. It is a fourth degree polynomial. It's not quadratic, but we can factor it using the quadratic method that we use. The key is that the first exponent must be double the second exponent, and the last term must be a constant. Okay? All right? So if you have an exponent, half that exponent, no variable whatsoever, that's when you can do this. And we're going to begin by the x. So 3 times 10 is 30. That number goes on top, so the first number times the last number. That middle number, the negative 11, goes on the bottom. And then I look for two numbers and multiply to 30 and add to 11. I don't worry about the signs right now. It's 6 and 5. The bigger number always matches the sign of the bottom number, so the 6 is negative. And in order to multiply to 30, well, they're both negative. Okay? And now that I've found this, the negative 6 and the negative 5, here's the significance of the negative 6 and the negative 5. That they together, they make my middle term. Okay? I'm going to do this a little differently than I have in the past. I'm going to rewrite b of x. The first term is perfect how it is. And the last term is perfect how it is. What I'm going to do is rewrite the negative 11x squared using the negative 6 and the negative 5. But the question is, if it's a negative 11x squared, then the negative 6 and the negative 5 must be x squareds. So now if we combine like terms, we get this, okay? So here we are. I rewrote that polynomial, and the reason I did that is because I wanted you guys to fully understand what goes where and why. Now these just go into these squares in this order. And you got to know that the middle is x squared now. It's not just x, because the middle is x squared now, not just x. And then we just start taking whatever the most we can take out is. So between 3 and negative 6, the most that I can take out is a 3. Remember, the sign of the number here will match the sign of the box you're closest to. So positive, positive. It doesn't matter that that's negative. Now there's 4 x's here and 2 x's here, so I can take out at most 2. I can take 2 away from each of them. Down here, my first box is negative. It doesn't matter that the second box is positive. I will take out a negative. So I'm going to have the sign here match whatever box I'm touching. Between 5 and 10, I can take out a 5. And there's no x's for the 10 to give, so that's it. And now I look this way. Between the 3 and the 5, can't take anything out. But between x to the 4th and x squared, I could take out x squared. Between negative 6 and 10, I can take out a negative 2. And then x doesn't have anything. And here we are. This has been factored into 3x squared minus 5 and x squared minus 2. Okay, last one. This one, this is a cubic polynomial with 4 terms. So we try to see if it'll factor using the box. Let's give it a shot. So we put everybody in the box and we just start taking stuff out. We take out an x squared here. We take out a 2 here. We take out just an x here. That's all they have in common. And we take out a 5 here. And this is x plus 5 and x squared plus 2. The order doesn't matter here, you guys. Okay. Here are 2 representations of p of x. They give it to us here in standard form. Technically 3 representations. Over here they gave it to us in factored form. And then here's a graph. Okay, I'm confused now. Is that the graph of p of x? If they say so. Yeah, I guess it is. All right, so now the question is, how many non-real zeros does it have? Ooh, a good one. I can tell that it has 1 real one from the graph. I can also tell that it has 1 real one from this factor right here, where 1 is a real 0. What I'm left with is that right there. How many zeros will I get from this guy? And will they be real or not real? Well, if you were paying attention in class, you learned that a square with a plus sign always leads to imaginary zeros. Because step 1, we subtract, and we end up with a square equaling a negative. So that's going to give us a plus or a minus, and then something with an I, in this case 3. So 2 imaginary zeros, and that's right here. Ah, what happened? Did I switch to an eraser somehow? Okay, it's 2 of them. I want you to make a correlation here. How many total zeros did we have? Okay, how many total zeros did we have? Well, I had 2 imaginary ones and 1 real one, so I had 3. And random question, no reason I'm asking this. What's the degree of this polynomial? Also 3. Oh, interesting. Okay, let's go do the next part now. We're going to determine the zeros, use a diagram, if it helps. So here I have x to the 4th minus 256, and I notice a difference of 2 squares. So this is going to factor to x squared plus, is it 16? And x squared minus 16. All right, the square root of 256, 16. Now, you guys, what we are left with is something that doesn't factor, because the sum of squares doesn't factor. If you remember from earlier, a square with a plus sign, just like here, a square with a plus sign, always ends up leading us to 2 imaginary zeros, okay? So I can already kind of see this. I can see the future. I'm a fortune teller. I can see 2 imaginary zeros coming out of here. This is a difference of squares again, all right? I can either factor this further into x plus 4 and x minus 4, Or I can just solve it algebraically, saying x squared minus 16 equals 0. Whatever is your preferred method. But here I am. I have found a 0 at -4 from this guy. I found a 0 at +4 from that guy. And then from here, I know that if I subtract the 16s and square root both sides, I will get 4i plus or minus. So 4i and -4i. All right. Now I could have written this a little shorter as plus or minus 4 plus or minus 4i. That's the same thing as this. Either way, these are all the zeros. And now another random question. How many total zeros? 4. 1, 2, 3, 4. And again, totally random, no reason that I'm asking this. What's the degree of this polynomial? Oh, interesting. Interesting. 3, 3, 4, 4. Is this just random coincidence? Spoiler alert, it's not. The degree of a polynomial will always match the total number of zeros, all right? Real, imaginary, combined, total, all right? So not x-intercepts, but real and imaginary zeros combined. Total number of zeros will match the degree. This one, I can factor this nicely, because I just need to see what multiplies to -36 and adds to -5. I'm seeing 9 and 4 with a -9 and a +4, which means I can go straight to the factors, you guys. I don't have to go to the box if I don't want to. If you want to, feel free. But I don't go to the box when my a value is 1. I can just put these two numbers right here. But here's a key difference. Before, we used to just put x and x in our parentheses. If we did that here, we would be so wrong, because this is a 4th degree, all right? And x times x is not x to the 4th. This is x squared and x squared, all right? I'll teach you a little cheat. What goes in here matches what's in the middle. Okay? Alrighty. So now I have plus or minus 2i here, solved very similarly to how I solved this one and this one. So I'm not going to work this out. I want you to be able to do it on your own. And then this one factors into x plus 3 and x minus 3. So here I am. Oh, shoot. Okay. Here I am with the zeros of plus or minus 3 and plus or minus 2i, a grand total of 4 in my degree 4. Here's a cubic polynomial. We're going to go factor it. Love the box. It took me some time, you guys, to love the box as much as I do now. But I do love this box. All right, I'm not explaining as much, you guys. I want you to be able to do this independently. Check along. If you don't understand why, try it. Try it on your own. Get stuck. Keep looking. Go back to when I did explain it and see if that helps you understand it here. What this means is that this thing right here factors into x plus 3 and x squared plus 9. So I've got a real 0 at -3, and then I've got two imaginary zeros at plus or minus 3i. This is exactly the same as this one. So here I am with a degree 3, and holy moly, 3 total zeros. Okay. Which graph represents this function? Let's see. Is just the fact that it's even and positive going to be enough? Nope. The fact that this is an even degree and positive leading coefficient rules out this guy who's clearly odd. All right? But I don't fully know what's going on here. I guess what I can use to help me figure this out is x-intercepts. So I'm thinking factor. And the first thing I want to factor, you may have forgotten because we haven't done it in a while. But the first rule of factoring, if you remember, this was on my board for a long, long time. You take out the GCF. And here there's a GCF of 2. And that GCF of 2 was hiding this difference of squares from us. Mistake. That was a 4. So now this factors into 2 times x squared plus 4 and x squared minus 4. And then this is 2 times x squared plus 4. And this guy factors further into x plus 2 and x minus 2. So I should have zeros at -2 and 2 with multiplicities of 1. Remember, these guys, these parabola-looking things at those make these multiplicity 2s. It's this guy. This is the only one that has zeros at -2 and 2 with a multiplicity of 1 each, all right? That's cubic. That's a multiplicity of 3 or any higher odd number, but definitely not 1. So this is our guy right here. We're going to change one factor of the function blah, 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 so that it has 3 x-intercepts. Okay, let's see what it has now. Right now it has 1. This one is fine. At +3, there's this kind of a 0. All right? This right here currently is making imaginary zeros. It probably does a little dip and it just keeps going up like that. If I were to change that plus to a minus, then suddenly I have x plus 5, x minus 5, which is 2 more x-intercepts, one at -5 and one at 5. So yeah, I would change this factor like that. That wasn't up to their normal level of challenge for the question right before spiral review. All right, you guys, factor the quadratic by doing this. This is really, really interesting. It definitely helps going into our next lesson. All right, so I'll do it, even though I don't like to do the spiral review. I like you to review. Let's see what happened here. I got x squared, so they put x and x. Remember how always the first guy goes in the first box and the last guy goes in the last box. So now I need to make a -20, but also a +1 when I add these 2 boxes. All right? So I'm thinking a +5 and a -4. They multiply to make -20, and then a 5x and a -4x adds to make that x right there. So it's like a little bit of like deductive reasoning or working backwards. Okay. And on this one, we have the x squared here, which means we can only have x and x going on here and here. And then we have the 8 here. And so that can be a number of things. It can be 4 and 2 to make the 8. But if it was 4 and 2, then we'd get 4x and 2x. And they would add to 6 instead of -9. So now that I made that mistake, it's easy for me to tell a couple of things. One, that 2 and 4 aren't going to work. I need 8 and 1. And 2, the 2 positive numbers didn't make a negative, so I also need these guys negative. Okay. We were supposed to go further and find the zeros here. So if x minus 8 is a factor and x minus 1 is a factor, then the zeros are 8 and 1. If x plus 5 is a factor and x minus 4 is a factor, the zeros are negative 5 and 4. Okay, there you have it.